Okay, when I left you mere seconds ago, the dog has been in here chewing things up. When I left you mere seconds ago, I told you I was going to show you a situation in which actually it might become obvious to you that you committed omitted variable bias. In the example I gave you a minute ago, you're liable to pat yourself on the back and say what a great job you had done. But it is possible for omitted variable bias, and I've had this happen a couple of times in my own research, and it's definitely something that I keep an eye out for. It's a very handy thing to know. And also it's something I often put on the exam, by the way, is an example of this next issue right here. I haven't written the exam yet, but it's a very popular question with John Harvey. And that is, sometimes you will get, because you omitted a necessary variable, you will get the wrong sign on a coefficient, but a t-score so big that had you hypothesized that sign, it would have been significant. So it would be like if you got a negative number on hours of study, but a really high t-score. And you're like, well, that's kind of weird. Why would that happen? I'm going to tell you why that would happen. Okay, so what I did was here, let me double check this real quick before I skip over this. Maybe true. Oh, yeah. Okay, yeah. Yeah, let's do that one first. Okay. All right. Let's say that the following is the true regression. And then you're going to estimate the wrong one, all right? So we've got grade, oops, I just put a J there for some reason instead of an I, equal to beta sub 0 plus beta sub 1 hours sub I plus beta sub 2 awake sub I plus the stochastic error term. All right, I got a new variable for you. That is the number of consecutive hours you have been awake before you took this test, okay? And a couple things about it. One, the reason I'm including that is I'm trying to reflect the impact of people pulling all-nighters. That yes, I studied the same number of hours as somebody else, but they spread their studying out over 3 days. I did mine over the last 24 hours. I haven't been to sleep yet. And so presumably that would be a negative impact if you hadn't listened. So it's a number of consecutive hours you've been awake before you took the test, number of consecutive hours. Now, actually, that's not really going to have a negative impact until it gets to like a high number. I mean, because obviously if you're awake for 2 hours instead of 1 hour, is that going to make a difference? No. 3 hours instead of 2 hours make a difference? No. I mean, obviously you would probably be awake for 3 hours before the test, and that would not be a bad thing. And I'm going to show you how to reflect that later. I'm going to show you how to, that's going to be the next chapter. So there's really a better way to describe this variable than the way I have it right now, but I'm going to save that for the next chapter. For now, let's just pretend that indeed this will pick up the impact of people who are pulling all-nighters and therefore not very well, okay, I might have a personal confession. I once stayed awake for 3 straight days for a Soviet foreign policy exam. And it's because I hadn't done the reading. So, man, I was like, I got to do all this reading. And I went to all my other classes. And so I went in to take the test, and I'd read everything, and I could not think straight. So it was really hard to, it's all essay, really hard to form a sentence. For the final, I didn't get all the reading done. I got plenty of sleep. I made somewhere around an high 80s on the one where I stayed awake for 3 days. I made in the high 90s on the one where I didn't, and thankfully pulled out an A in the course. So this is picking up the impact of people pulling all-nighters, and it should be, we're expecting it to be negative. But let's say that instead you run this regression because you foolishly think to yourself, well, I just want to see the effect of all-nighters. Grade sub I is equal to beta sub 0 plus beta sub 2 awake plus stochastic error term, right? You think that's the true equation, so you run that, and you get a positive sign on awake. You're like, wait a minute. I was expecting people to stay awake for hours before the exam to be a negative. Well, the problem is that there's going to be some correlation between these two, all right? that people who stay awake are also going to study more hours. People who are staying awake for consecutive hours are also doing so because they're studying for the test. All right, so it's not because they stayed up, let's have another beer. And so they're staying up to study for this test. So there's a correlation between these two. You need to pull out how much of it is just from being exhausted. And yet, you also studied, all right? So there's a positive impact from being awake, and there's a negative impact from being awake. What is the positive impact? It should show up over here. You were studying. What's the negative impact? Oh my God, you're so tired you can't think straight, right? So those are two separate things. But the computer, if you only ask it to run this red one, if this was affected by both hours and awake, but you only ask it to explain with awake, it's not going to know that, well, now bear in mind, some of that time they spent studying, so you really need to take that into account. The computer says to you, no, you need to take that into account, not me. All I do is run the regression. You need to do your homework. And so, as a consequence, you should have run this. So, when you just run this, you are picking up, because you didn't include it separately, because you didn't tell the computer to take it into account separately, you were including the effect of hours from the true regression, and there's likely to be a positive correlation between these two numbers. So when the computer runs this, like, oh, people who stayed awake longer tended to get higher grades. Well, that's because they studied more, all right? But it also is true that, yeah, but when you stayed awake for 20 hours before the exam started, or 24 or 48, or in my case, 72, then at that point, the impact of this is actually the pure impact of this. The impact of just this is negative. So, when the bias that is created, now, it could still be a significant relationship. It could still be significantly, if these were highly correlated, they could still be a significant relationship. You get a pretty decent t-score. You get a pretty decent adjusted R-square, but you get the wrong sign. Beta sub 2 ended up being positive and not negative. And that is absolutely a key indicator of omitted variable bias. And what you have to do then is stop and think, wait a minute, I know that doesn't make sense. All right? I know it doesn't make sense that the people who are exhausted, the more exhausted you are, the better you do on the test. And once again, as I mentioned earlier, there's a better way to measure this, because actually at low levels of awake, it's not going to have any impact whatsoever. It's really the very high levels, maybe, actually I guess I could measure it that way. The number of consecutive hours you've stayed awake above 18 or something like this. Right? We could do it that way. That's actually probably a better idea. But anyway, I have another suggestion in the next chapter. And so you got the wrong sign on beta sub 2, but a t-score that would have been significant had you hypothesized positive, but you didn't. You hypothesized negative. And remember where the t-score works. As soon as you got the wrong sign, it fails. On a one-sided test, which is what you would be doing 99.9% of the time, because you would have hypothesized a sign, it would fail. All right, so then you got to think to yourself, well, wait a minute. What might be correlated with awake and have a positive impact? And so I'm going to show you a table to figure this sort of thing out here in just a minute, because as a matter of fact, there's a homework question that requires you to do this. But at this point, you have to ask yourself, the direction of the bias is going to be equal to, oops, that should be that looks like expected sign of omitted variable times direction of correlation with included variable. Direction of correlation with included variable. I don't know if you can hear Melanie talking or not, but it must be about 11, I guess, because she teaches 11:01. She teaches 4th grade, and she is now meeting with her class. And you hear things like, "So, why haven't you done any of the assignments from the last 2 weeks?" I forgot. I said, no, you didn't forget. You didn't forget when we would have been in class for 8 hours a day, 5 days a week. You didn't forget. So anyway, they try to say it nicely but firmly. Anyway, she's in the middle of the fun part of the class right now. That usually happens at the end. So-and-so, would you stay after the Zoom session is done with all the other students? It's never a good thing to hear. All right, anyway, I can hear in the other room. Now, that looks like a mess, doesn't it? Bias is equal to expected sign of omitted variable times direction of correlation with included variable. It's actually not that complicated. Let me give you an example. If I give you an example, I think it's a lot easier to understand what it's saying. I don't have that memorized. Well, I guess it's kind of, well, once you see it, it's not really something you need to memorize because it's just kind of common sense. All right, so which direction is your bias? In the first example I gave you on the previous video, the bias was actually positive. It biased the variable or the coefficient in the same direction as the included variable. It made it bigger than it should have been. It was still positive, but it was a bigger positive coefficient than it should have been. In this case, it biased it to become a negative number. Or if it doesn't even quite become negative, it could just become a smaller number than it really should be. And let me show you. I think it's much easier to figure this out with an example. Once again, let's do grade. And let's say that this is the true equation. Let's say that we asked God or Buddha or whomever, and they said, well, you want to know what determines someone's grade? Well, here, it's this. I'm going to make a big regression here. Grade sub I is equal to beta sub 0 plus beta sub 1. What do we got, hours again? Yeah, hours sub I plus beta sub 2, SAT score, plus beta sub 3, ABS, that's going to be absences, plus beta sub 4, that awake thing we just had. I'm running out of room here. Plus beta sub 5, the number of beers you've had in the last 5 hours or 10 hours or whatever, plus your stochastic error term. Put all my sub i's on there. Okay, so you've asked a supreme being, what is the true relationship, what really determines people's grades? And this, let me make sure that's visible on the thing. Yeah. And this supreme being has said, well, it turns out to be that your grade is a function of the number of hours you studied, how well prepared you were for college before you got there. Well, we don't really have a number for that, right? So let's just use SAT score. That your SAT score reflects how well prepared you were for college, especially in the intro class. I got to tell you, that's a huge difference in the intro classes, how well prepared students were by their high school experience for college. Some kids, I mean, senior year, probably not so much at TCU, but senior year is like, 5 study halls in one class. I went to a Catholic high school, and my senior year was, my parents once asked the principal, John does nothing but work. Is that normal? And he said, it'll make college easy. And it was absolutely true. My first year of college, taking honors physics, honors English, I think I took regular calculus, honors German. It was easier than high school. My God, I had spare time. Anyway, so that's a really big deal, how well prepared you are from high school. And let's say the SAT score reflects that. Here's the number of times you've been absent from class, or the percentage of times you've been absent, whatever you want to make it, it doesn't make it. Here's that same thing we just talked about. How many consecutive hours have you been awake? And then, how many beers have you had in the last 5 hours? All right, I don't know how much you drink before you take a test, but it's something to bear in mind. Now, we're expecting the coefficients, of course, to be, and let me maybe jot this down underneath. We're going to expect that one to be positive, that one to be positive. Here's absences, that's going to be negative. Here's capturing the effect of being awake for consecutive hours, therefore being exhausted, so that's negative. And here's your number of beers. I'm sorry, why did I do that? Good Lord, I hope I haven't encouraged you to do something bad. Let's see here. Negative. All right, so that's the number of beers you had before class. All right, but, okay, we're going to omit some variables. And let's say, what did I do here, John? What if you left out here? I think I was just going to do Hours. Yeah, okay. All right. Then, here's my question. If you leave one out, and there's a fly on the lens of the camera. Let's see if it actually crawls into the actual lens part. That would look really cool. It's going off to the strap. All right, anyway. Let's say you ran this omitting one of the variables, all right? And what we're going to do is, in turn, talk about the impact of the omission of that individual variable. You've definitely included hours. And the question is, how does the omission of each individual variable affect the coefficient on hours? All right, so check this out. Uh-oh, that's not a very good pen. I really like this chapter a lot. Omitted, expected sign. What else have I got here? Correlation with hours, and that's going to be, we're always going to remember to include that. And direction of bias. At the end of of Melanie's class, they read from Harry Potter, and I have to tell you, I kind of hang around in the kitchen so I can listen. Second year, Harry's just gone back to Hogwarts. All right, let's see, and let me write these variables over here on the left. SAT, absences. Awake next? No. SAT, yeah, awake. And beers, 4, perfect. Okay, and let me explain to you what I'm doing here, because there's a homework question where you have to do exactly this, all right? You have to make a little chart like this. Okay, make it easy on yourself. Now, here's what you're doing. Here's the point of this exercise. Let's say you've run this regression, and you have left one of the variables out. You've potentially included everything else, but you've left one out. What you're asking is, how would leaving out SAT affect the coefficient of hours? We're only thinking about the impact on the coefficient of hours on beta sub 1, right? All of this is asking, what impact would this have on the coefficient of hours? All right, we can fill out this first column nice and easy. Right? The first column just says, if you had remembered to include it, what would its expected sign have been? Well, if I'd remembered to include SAT, it would have been a positive sign. We would have expected it, as I already said, to have a positive impact. That's all we're doing in this column. Very simple. Absences, I would have expected that to be negative. Hours consecutive awake, I would have expected negative. Number of beers, I would have expected negative. And look, perhaps consistent with number of beers, I drew that one sort of crooked. All right, that's just asking, had you remembered to include it, what would its sign have been? But you didn't remember. Second question, how would you expect SAT to be correlated with hours? And by the way, in the next chapter, no, 2 chapters from now, I will show you a specific way to calculate this, to calculate the correlation. But for right now, let's just say, hey, would we have expected these two to move together or move in the opposite direction? And I'm assuming that SAT score and number of hours are going to tend to move together. It's kind of funny, my friends that went to Knoxville Catholic High School and then went on to University of Tennessee with me, the ones who had been like okay students in high school are like, oh my God, they're asking if I'm willing to major in their subject because my grade is so much better than everybody else's, because we were so used to doing nothing but study, which was actually rather painful. But anyway, indeed, the higher SAT scores not only meant that you were better prepared for high school, for college rather, but you also tended to study more because that's where you got that background. So we figured these two are going to move together. Hours of study and absences, I'm going to tell you from experience, people who don't come to class also don't study. All right? So there's a negative relationship between hours and absences. Now this is the number of consecutive hours you have to stay awake for, and let's assume that this is positive because Well, yeah, but the reason you're staying awake is in order to study. All right. Again, we'll have a way later to test the relationship mathematically, but right now let's just kind of think about what it might be. The longer you're staying awake, the more hours you studied, but then of course that's, also there's going to be a negative impact from being awake. Beers, I don't know that there'd be any specific correlation, probably negative. Probably the people who are studying are not studying with a six-pack. Just so I can have a different example here, I'm going to have a plus plus, a negative negative, a negative plus. I want one where there's no relationship at all, okay? So that I can have a different example. So let's just say there's none. All right. So now the really important column over here. What would be the direction of bias on beta sub 1 if you left out SAT? This times this is this. And that was that equation that let me circle it here on my notes and I'll show you. That was that equation I was showing you a minute ago before I erased it. Let's see, right there. Bias is equal to expected sign of omitted variable times the direction of correlation with included. Expected sign of omitted variable times the correlation with the included one. If I left out a variable that would have been positively correlated with hours and would have increased someone's grade, then the computer is going to assume that what was really caused by SAT was actually caused by hours. And that's not true. It's going to give me too large of a beta sub 1. It's going to cause beta sub 1 to be larger than it really is because it's not taking into account, well now wait a minute, but that person also had a better high school background, so they're actually more efficient when they study. Not only do they study more efficiently. And we really needed to separate those two. But because you didn't separate them, it assumed that because these two tend to move together, it assumed that the variation caused by this was actually caused by this, and so beta sub 1 is an even bigger number than it should be. Absences, they're negative, negative. So what that means is then that, let me tell you, first of all, the simple math of it is going to be negative times negative is positive. What that's saying is if you leave absences out, and absences truly should be there, that's our implicit assumption here all through is that these should have been there, and you left them out. If you leave out absences, then part of why your grade was high in this class was you had a low number right here, right? And presumably the people who have a low number here have a higher number here. So part of why you did well on the exam was the hours of study. But it was also because you actually came to class. And so you didn't have to try to figure out on your own what the heck that graph means. And I know we've all been there from missing class into the econ class. You're like, well, crap. There's this complicated graph. I'm about to figure it out on my own. And so a lot of your studying is just doing things that would have been covered in class had you gone to class. And so if you don't miss class, the fewer absences you have, the higher your grade. The more absences you have, the lower your grade, all right? And because people who miss class also tend not to study as much, what's going to happen is that the computer, if you leave this variable out, the computer is going to assume that the increases in grades that were really caused by people attending, by the opposite of this, was caused by hours of study. No, it wasn't. It was caused by people actually coming to class. That it's not separating out the individual impact of how much more efficient your studying is if you come to class. All right? So 1 hour of study isn't equivalent from one student to the next. Some of it is you had a better high school background. Some of it is, and also you came to class, so your studying isn't remedial, your studying is on top of what you learned in class. All right? But you leave that out, you're going to bias beta sub 1 bigger. Leaving both of those out, of course, would bias beta sub 1 a lot bigger, and you would never notice. Because you would be like, oh, that's interesting. Boy, hours of study is like just about everything. When in fact, it's not just about everything. You left other stuff out that is correlated with hours of study in a way that would make beta sub 1 bigger. What about hours being awake? And we already covered this a little bit, but you can see here that that's going to be negative. That people who study more are also going to, and it's probably not going to be a very high correlation here, but let's pretend there is a very high correlation. People that study more might also tend to be the ones who stayed awake for the last 72 hours and therefore are not working at their peak. And so that's going to cause beta sub 1 to be a little bit smaller than it should be. It's not, again, it's not differentiating quality of study here, all right? It's not different. If you just put hours in, you're not differentiating among the kids who had a better high school background, who came to class every day, who actually got a decent amount of sleep and didn't wait to the last minute to study. And these two things would have inflated beta sub 1. This would actually have made it a little bit smaller. And potentially even negative, although honestly I doubt it with what I expect the parameters would be in this situation, but it could potentially make it negative. And it would clearly make it smaller, all right? Because some of those people who studied more actually did so by staying awake for 72 hours, so beta sub 1 ends up not being as big. And then the last one is, what do I write here? I just wrote nothing. Nothing. All right. That if there's no if a variable you left out has no correlation with the one you included, it's not going to cause any bias. All right, it's not going to cause beta sub 1 to be affected. It probably will in a minor way because any two series of numbers are going to end up having some correlation with each other, but probably nothing too strong. So by leaving out a variable that isn't correlated with the one you put in is likely not to cause bias in the one you left in, all right? Okay. So this is one of the first things I look at when I'm running something and trying to figure things out. And it's like, you know, what if I had a positive sign on interest rates? There on the far right. What if I had a positive sign on it? Then I would have, I'm sorry, let me finish that sentence. But still 1.71 as the t-score or something thereabouts. I'd have been like, crap. That would have been significant had I hypothesized a positive sign for interest rates, and I didn't, and there's no logical reason to hypothesize a positive sign for interest rates. I must have left something out. And so then you go back to the theory again and figure out what you left out. Of course, it could be I left many things out here, and even though I got the right sign, perhaps those magnitudes are not quite what they should be given omitted variable bias. All right, let's see, what time is that? That was another 27 minutes. A long chapter here to talk about. This is going to take me another video, I think my first three-part chapter, but such a good chapter. And I wanted to make sure that you had a good feel for all this. God, I wish we were doing this in person. We'll be doing some, obviously, in Zoom. But it's so much easier when I can get immediate feedback to tell if people are understanding things or not. But hopefully this at least serves as an introduction and a reference to go back to. And the chapters are well written. You may find them painful to read because it's econometrics, but they are really well written compared to other books. He's really worked hard to make this something that is a useful guide. If you can afford to do so, don't sell this book. This is a really good book to hang on to so that if one day when you're in a position where you're needing to do this stuff yourself, just a fantastic not revision, review to look through that. Okay, let me stop this and then I'll do the third video for this chapter.